If you haven't already, take a moment to answer these problems, and then we're going to try them on going over them together. So, what did you get for the first one? The square root of 25 is 5. Okay? And then we'll go in order. What's the negative square root of 25? That'd be negative 5 because the negative's out in front. And then what about this, the square root of negative 25? Yeah, this one is going to be not real. Okay, because you can't take the square root of a negative. Now, what about the cube root of 8? 2. That's because 2 to the third power is 8. And so what we're noticing here is the cube root undoes the cube. They're inverse operations. What about the negative cube root of 8? That'd be negative 2, right? What about the cube root of negative 8? So actually, you guys, if I took negative 2 to the third power, I would get a negative 8. So actually, when the index is odd, we can have a negative inside. So this would actually be negative 2. Now, the question of how to do this on the calculator came up. So I'm going to show my calculator. You will want a graphing calculator for this class. I highly recommend the TI-84. And this is the color screen edition and the pink calculator. So what we're going to do is if we want to do square root, you see that right above the square is the square root. That's because the square and the square root are inverses of each other. So if I just go second square root and I plug in 25, I'm going to get 5. So I can check all of my answers. I can go square root of negative 25. Now notice I used this little negative button down here. And what happens is my calculator says error. What does it say? Non-real answer. Now, some of you asked, how would I do the cube root? Should I just put a 3 out in front? Well, no, that's not going to work. So if I go math, oops, I got to get out of there. Okay, so that's non-real is the negative square root. But if I use the button math, you're going to look down. Here's cubing. There's cube root because there's the index. And then if you want any other root, because how many different roots can you take? Yeah, an infinite amount. So you would have to tell the index first. So let's try the cube root. We're going to do the cube root of negative 8. If it was not real, it would tell us an error. But it says negative 2. And that's because we said if I take an odd number of negatives, I can get a negative answer when I take it to an odd exponent, right? That would be give me a leftover negative. Okay, what if I want, now below here, there's some other, like let's say the fourth root. Okay, I'm just going to scroll down because we talked about cube root, but let's do fourth root. The fourth root of 16, does anybody know what it is? It's 2. How would I do fourth root? Well, first I would have to tell the calculator 4. I would go math. I would click that x root. The x root is 5. And you see what it does? It makes the 4 the index. So you have to tell it the index first. And then we would plug in 16 and we would get 2. Yes, question. Yes, so only when and there should be a way that we could write that someplace, but maybe let's take out another piece of paper and let's say, so what about negatives inside the radical? Okay, so sorry I didn't give you enough space on that, so you might just take out another piece of paper because we're going to come and do some other notes too. But the negative inside the radical, if the index n, if n is even, okay, and you have a negative number here, this will be not real, okay? If you have the index n is odd, the negative is real. So you're just going to look and see about that index. And that's because if I have negative 3 squared or to any even power, I'm always going to end up with a positive. If I have a negative 3 to an odd power, I will have negative 3 times negative 3 times negative 3, which would be what? Negative 27. And that, because I had an odd exponent, I was able to get a negative number as a result, right? So that's because all the evens, if I have an even number of negatives, I will end up with a positive. Does that kind of make sense? Okay, let's go back to some of these problems here. So we're going to evaluate, if possible, the square root of 9 is, okay, what about the cube root of 1,000? What number times itself 3 times gives you 1,000? 10, good. What about the square root of 8? Says if a calculator is needed, approximate to 2 decimal places. So that's not the cube root of 8, that's the square root of 8. So if we do the square root of 8, we get a decimal and we want to round it to 2 places. So what did you round it to? 2.83, because of the 8 next to the 2, we would round that up to a 3. Okay, what about the fourth root of 17? So again, we're going to have to use that idea of the index. So if I go, I'm going to have to plug the index in first, 4. Then I go math, scroll down to my x root, take the fourth root of 17, and I get 2.03. 2.03. Okay, now let's take a look at this one. What's going on here? We have the fourth root of 9 to the fourth. And this is the idea that the nth root undoes the fourth power. The fourth root, undoes the fourth power. So if I have x to the fourth and I take the fourth root of it, what would I get? I would get x. So do you see how the fourth root undoes the fourth power, and what would be left? What about here? The square root of 7 squared. That's the same thing as the square root of 49. And by the way, nobody ever puts a 2 as the index. So this problem is exactly the same as the square root of 49. What would that be? 7. Good. Now what about this little tricky situation? You see where the negative is located. All of these problems are very similar, but the negative is floating around in different places. So this would be the same thing as what? The square root of negative 49. And what would you say the answer to that is? Not real. Excellent. What about here? If I square a negative 7, I'm going to get 49. So what's the square root of that? Yeah, 7. And then here we have the negative on the outside. And so the square root of 7 squared, and you want the opposite of that, is going to be negative 7. You see how the square root and the square undo each other. So these are literally undoing each other. And then we're keeping that negative from the outside. What's the cube root of 125? 5. Great. And what about the cube root of negative 125? Negative 5. Good. And then this last one, the negative cube root of 125. Also negative 5, right? And then on the last row, what about the fourth root of negative 16? Not real. And that's because, how did you know it was not real? Yes, it's an even index. But what about the negative fourth root of 16? Negative 2. Excellent. Okay. All right. Let's talk. I'm going to stop this one and we'll talk about the Pythagorean theorem in the next video.